So today for this video we're going to take a look at a couple laws of logic, and the first one is called the law of detachment. And what the law of detachment says is that if you have a true conditional statement, so if you have a true if-then statement, and you know that the hypothesis is true, then the conclusion of that statement will also be true. So let's take a look at how this applies. We have some information here that we are told is true. So we have a true if-then statement. If Alicia scores 85 or greater on her test, she will earn an A as her final grade. So there's our true if-then statement. And now we have some more information that's true. Alicia scores 89 on her test. The question it says is, what can you logically conclude? So if we apply the law of detachment here and we realize that we have a true statement, we have found out right here that the hypothesis is true. She scored 89, which is 85 or greater. So we have a true hypothesis for our true statement. What we can conclude is that Alicia will earn an A as her final grade. Another example using the law of detachment would be maybe a more geometric example would be this one. If point D is in the interior of angle ABC, then the measure of angle ABC equals the measure of angle ABD plus the measure of angle DBC. And then we have this picture that we're supposed to use as information for this problem. So we have an if-then statement that is true. If D is in the middle of the angle, then when I connect the vertex of angle ABC to point D, breaking angle ABC into two parts, then the measures of those two parts will add up to the measure of the original angle. That's what this if-then statement is telling us. So the question is, what can you logically conclude about the measure of angle ABC? And so just like before, we have our if-then statement, we have our picture that shows that the hypothesis of this statement is true. Point D is in the interior of angle ABC. So we can logically conclude that this conclusion will be true. So we can conclude that the measure of angle ABC equals the measure of angle ABD plus the measure of angle DBC. Now there's one more example here. I guess it's technically two examples, part A and part B. So I would encourage you to pause the video and take a look at these two examples in your student edition. Okay, let's look at the next law of logic. This one is called the law of syllogism. Now this one's a little bit more complicated, but it's really not too bad. It says that if you have two true conditionals, with the conclusion of the first becoming the hypothesis of the second, then there is a third true conditional, which will have the hypothesis of the first and the conclusion of the second. So that sounds a little complicated. Let's look at what it means in symbols. So if we have these two statements that we know are true, that would say if P then Q, and if Q then R. If both of those statements are true, and we notice that this conclusion is used right here as the hypothesis of our second statement, if those are both true, then we can say that there's a third statement that's true that starts with P and has the conclusion of R. If P, then R. Now I think this one's a little bit easier to look at if we look at maybe some more concrete examples. So let's look at example 3 here. Assume that the set of conditionals is true. What can you conclude using the law of syllogism? If Kenji plays the trumpet, then he plays a brass instrument. So there is one true statement. Hypothesis says Kenji plays the trumpet. Conclusion says he plays a brass instrument. Our next statement starts with if he plays a brass instrument. Notice the repetition there. The conclusion is he is a member of the marching band. So to apply the law of syllogism, we can see here, we need to recognize that this he plays a brass instrument is used twice. It's used as the conclusion of one of the statements and then as the hypothesis of the next statement. So what that means by the law of syllogism is that we can take that first hypothesis, if Kenji plays the trumpet, and connect it to the last conclusion, then he is a member of the marching band. And sometimes I describe this as if you were like going on a road trip. If you were going from, let's say, St. Louis to Bloomington, and then from Bloomington to Chicago, that is the same as saying I'm going from St. Louis to Chicago. Because it's like Bloomington is the end of the first part of your trip and it's the start of your second part of your trip. So in reality, you kind of took a trip from St. Louis to Chicago. And that's kind of what's happening here. This Kenji plays the trumpet. That statement is the hypothesis of our first true statement. It has a conclusion that's used again as the beginning of the next statement. And then we have this conclusion of the second statement. So to apply the law of syllogism, we just connect that first hypothesis to the last conclusion. Let's look at another example like that. If points A, B, and C are collinear and B is between A and C, then ray BA and ray BC are opposite rays. If ray BA and ray BC are opposite rays, then the length of AB plus the length of BC equals the length of AC. What can you conclude? So again, notice we have two statements, two if-then statements. There's a phrase that's used as the conclusion of the first one, and then again as the hypothesis of the second one. So to apply the law of syllogism, we recognize that fact, and so we say, if points A, B, and C are collinear and B is between A and C, then AB plus BC equals AC. So try these next two problems, try those. See if you can come up with how you would correctly apply the law of syllogism on these. And let's look at one more example together. What conclusions can you draw from the following true statements? If you are climbing a mountain at an altitude of 28,500 feet or higher, then you are on the tallest mountain above sea level on Earth. If you are on the tallest mountain above sea level on Earth, then you are on Mount Everest. The conclusion is, the next piece of given information is you are climbing a mountain at an altitude of 29,000 feet. So for this one, we're going to apply both of these laws of logic that we just learned about. First, we're going to notice, okay, what are my conditional statements and what are my hypotheses and conclusions? So I have this conditional statement that says if you are climbing a mountain at an altitude of 28,500 feet or higher, then you are climbing the tallest mountain above sea level. And then we look and says, oh, hey, you're on a mountain that's at 29,000 feet. So we found out that hypothesis is true. So by the law of detachment, we know that we are on the tallest mountain above sea level on Earth. Then we look at the second statement that says if you are on the tallest mountain above sea level on Earth, then you are on Mount Everest. And that would tell us, hey, we already know we're on the tallest mountain above sea level on Earth, so our conclusion could be that you are on Mount Everest. So those are the laws of detachment and syllogism. The law of detachment is pretty straightforward. It's if you have a true statement and you find out the hypothesis is true, then you know the conclusion is true. The law of syllogism states that if you have two statements that are both true, and the conclusion of one is used as the hypothesis of the second, then a third statement ends up being true that connects the hypothesis of your first statement to the conclusion of your second statement.